It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome. This is day 17 of Advent of Code. With me is David. Hello, David.
I guess you're this side. Hi. And yeah, glad to be here. Let's do day 17.
Let's do day 17. And I am kind of hoping that this will be a difficult one. I want a challenge.
Yeah, it's going to be... let's see. Clumsy crucible. What's a crucible? The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. Have you heard about Gear Island before? I don't think so. I know Island and Desert Island, but not Gear Island.
Yeah, well, I guess there is Snow Island as well. We have been to Snow Island, but there was no snow. As you descend, your bird's eye view of Gear Island reveals why you had trouble finding anyone on your way up. Half of Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava fall. Lava ducts will eventually carry the lava through the city, but you make use of it immediately. Elves are loading it into large crucibles on wheels. I will find out what crucibles are. Is this just a pot?
It's a furnace where you cook clay things, no? Or like heat up chemicals, metals and stuff. Rings a bell.
The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, and so it can be hard to go in a straight line for very long. To get Desert Island the machine parts it needs as soon as possible, you will need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss while choosing a route that doesn't require a crucible to go in a straight line for too long. Fortunately, the elves here have a map. your puzzle input that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any particular city block. For example, each city block is marked by a single digit that represents the amount of heat loss if the crucible enters that block. The starting point, the lava pool, is the top left city block. The destination, the machine parts factory, is the bottom right city block. I am anticipating Dijkstra. Because you already start in the top left block, you don't incur that block's heat loss unless you leave that block and then return to it. So, to recap, we started here, number 2, but we don't count 2. We only count moving forward, and these numbers are heat losses, so we want to minimize the number. Because it is difficult to keep the top-heavy crucible going in a straight line for very long, you can move at most 3 blocks in a single direction before you must turn 90 degrees left or right. It doesn't really make sense to turn 180 degrees because then you would be passing through a path you have already been on. The crucible can't reverse direction. After entering each city block, it may only turn left, continue straight, or turn right. One way to minimize heat loss is this path. This path, which is this, so and so on. This path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. Directing the crucible from the lava pool.
So it's the entry direction that they've got drawn there rather than the exit. Like you enter each cell in a direction and you leave each cell in a direction.
Yeah.
And so they're drawing the entry direction, I guess.
Yeah. This path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. Directing the crucible from the lava pool to the machine parts factory, but not moving more than 3 consecutive blocks in the same direction, what is the least heat loss it can incur?
I think you were right about Dijkstra.
Yeah, but there is, of course, the twist of not taking more than 3 steps in the same direction.
But I think you can just discard things which don't meet that criteria and it will still work, kind of thing.
Yeah. Well, let's get started. And today I'm driving, right?
You are indeed. It's going to be challenging with JavaScript, but good luck.
Why do you say that?
Well, I guess it doesn't have to be, actually. My thought was, like, if you're doing Dijkstra, you would normally use a heap, but you don't have to use a heap. You can just, like, resort the list every time or something like that. And, like, Python has a heap off the shelf. I guess you could use a heap, a JavaScript library for a heap, though, so that's fine, too. If you need it. But you might not need it.
We'll see. We'll see. I'm sure there is a library for any data structure that we'll need.
There's a library for everything in JavaScript. It's like there's an app for that.
Yeah. All right. I will start by parsing where the light is, right? So I'll have my board, which is the usual.
Yeah, I still have to think every time, though, how to parse it.
There.
Oh, we always forget about... Oh, no, you didn't forget about trimming things. Fair enough. Well done.
Well, thank you. Now...
And that's broken my terminal.
Oh, shucks.
That's all good.
So we cannot just simply go to the block with the least heat loss because, for instance, the optimal path here to begin with actually starts with the 4, not with the 3. So, does it make sense to explore the whole space? That's kind of what Dijkstra does, in fact, right?
Yep. So, although it might exit at... Oh, yeah, no, it does. Always, yeah.
So...
Although, yeah, go on. Keep thinking. That does may complicate things.
I will have a notion of a stage where the stage is the coordinates. So the stage is... I am following your style and writing things down before starting to write code. And if I was using TypeScript, I would probably do a type alias here. But a stage is coordinate of where I am.
You don't want to do TypeScript?
A direction. No.
Okay.
And how many steps I can still take in this direction. Do you have a shorter name for this?
How
about steps?
Steps, I would have thought would mean like your distance so far. So I mean, it's like it is remaining is I can take.
Steps remaining in direction.
It is. Yeah, that's shorter for sure.
It's better.
What about remaining in direction? I don't know. Yeah, steps remaining in direction. I think that's short enough, maybe.
So, let us have.
What about direction count? Do you like that?
No.
Okay.
So let us have perhaps a set or a list. It doesn't matter. We will have... Oh, and also the stage needs to carry the heat loss, the accumulated heat loss. There. Now let us have the states that we are still exploring. So states to explore. And I think I'm going to use a set. No, because this is going to be an object, so it's going to be difficult to putting sets. So I'll have a list instead. Then I will have the states explored, which will also be a list. Or actually, this one is going to be a set. There. Now, while I have states to explore, I'm going to do a bunch of things, but I guess I need an initial state to explore. So initially, I am in my coordinate is going to be x is 0 and y is 0. My direction is I'm going to the right, or should I say to the east? I'm going to say to the right. My steps remaining in direction. I can take 3, and the accumulated heat loss is 0. But not only that, I also have another initial stage that is going down.
Is it 0 at step 1? Or is there... I guess it's accumulated,
Yeah.
so you accumulate it after you leave.
How about I not even define the direction? I'm thinking of special cases and things like that. I think I will not even define the direction to begin with. I think that will work out. Let's see. My stage to explore is pop.
Sure.
Then I need to check if I have already explored. So if my state to explore exists in states explored,
okay,
continue. Otherwise, let's add. So I'll have something like state to explore serialized.
Is JSON stringify guaranteed to be have the same output? Always.
In this very particular application, yes. But if you change the order of the keys or anything like that, then no.
Right. And I did learn that in JavaScript, like even though objects are kind of seen like as a dictionary, they are actually order dependent. So the order that you add them is preserved in all engines, as far as I know.
That is true of JavaScript. It's also true of Python, since Python 3.8, I think, 3.7, something like that. Hello, Nick.
Yeah.
Nick is on the
Hi,
chat.
Nick.
So, I'm thinking if all of these things are necessary for our states explored. The coordinate, for sure. The direction. Could it be that I want to visit the same coordinate in coming from different directions? Yes. Then
yes, and also
the steps remaining in direction, yes. But the accumulated heat loss, maybe not. That's what I'm thinking.
Yeah, I think that's fair. Although I think you kind of want to minimize by that. If you've reached that, if you do it breadth first search, then you will have... Oh, you actually know. Well, that's the thing, isn't it? You need to sort it. So if you should always visit it. That's what Dijkstra is about, right? Is that you sort it so that you reach it in the accumulated heat loss version first. So if you found a better path to that node, then you should take that path.
So, shucks. If I do the simple thing that I'm about to write, it's going to take forever, right? Because it's going to explore everything, and this is big enough that it matters.
No, I don't think so. I think you can explore everything.
Yeah, okay, let's continue. At least the small one I should be able to do. So let's see if I can get something right, and then we can try and get something faster. Okay. So, I'm starting to get the feeling that I will want to have the states to explore, or actually the states explored. I will want to grab things from inside. But anyway, we'll see that. We'll see about that. So far, so good. I am doing the usual detection of this work being done already. I will now write the case for what happens if my coordinate is the bottom right. So if my state to explore coordinate x is equal to the board length minus 1, like that.
Yeah. So.
And the coordinate y is the length of the board minus 1, like that. Then I have reached the end. And then I will check. Ooh, there is another thing that I need. I need to have in this state data structure the coordinates that I have been on, because I don't want to go over the coordinate that I have already been on.
Yeah.
I'll turn this into a list.
Just one thing. If you sort the states to explore every time at the top of that while loop by the lowest heat loss, then you're guaranteed to always find the shortest, explore the shortest path first. If you see what I mean.
I see what you mean. That is interesting. All right, I'll get to that.
Okay. Forget about that.
It's new. So this is the case in which we have reached the end. And by your comment, when we reach the end, are we guaranteed to have reached the end with the minimum heat loss that we can find? I think so, right?
Yeah.
So in that case, I suppose we can add the heat loss. So let's compute the heat loss, which is going to be the state heat loss plus, or I guess the state accumulated heat loss plus the heat loss of our current place on the board. Oh, how about we make this cute and so that we can start using board at I guess I will use this enough that it's worth having the coordinate.
Yeah, makes sense.
No, it really was board at coordinate y, coordinate x, and there.
Yeah, I'm not following why coordinates is an array.
Coordinates is an array because now we are going to accumulate all the coordinates that we have been on so that we detect that we are going to go over something we have already been on and we don't continue going there.
Right, you're accumulating the full path. Yeah, got it. That's cool.
So if that's the case, then I guess I don't like how this console log is hidden here and the stop condition is hidden there, but whatever. All right.
I don't see what you mean by hidden.
All our programs have this shape where we console log something in the end. I'm feeling like maybe I should have a variable here for like minimum heat loss or something, but we'll go with that. So if I have reached the end of the board, then that's that. I should also check that I have gone outside the board. But
Yes.
perhaps I could do like Nick said yesterday and not even put that on the work list to begin with. So we are guaranteed that
Sure.
if a direction or if a coordinate or if a state exists, then it has a valid coordinate. Yeah. Let's try and prevent work as soon as we can. So next, let's see. The states that we want to push, right? Suppose that's what's up. So I will produce states to explore, and then I will check if they are valid before pushing them on to the work list. So
Yeah.
for state to explore off, and here is going to be a list of states to explore.
I think. Are you going to run into an issue with the renaming of state to explore?
Yeah, next state to explore. Thanks.
Sure.
Let's see. I will want my state to explore coordinates, and I will want to go, for instance, up. So x is going to be my coordinate x, and y is going to be my coordinate y minus 1. My direction is that I'm going up. My steps remaining in direction is going to be if my state to explore direction is up, then my state to explore steps remaining in direction minus 1, otherwise 3. Then my accumulated heat loss is going to be heat loss, which I computed here. Then that is going up.
Is that right for the first state to explore then? Should it really be 0 at the very first one? Because you're adding it to the previous, but doesn't the first cell have a heat loss?
The first cell has a heat loss, but we don't use it.
Is that what they said?
That's what I understand, yes. I will try
Okay.
and convince you before I proceed.
Sure.
Because you already start in the top left block, you don't incur that block's heat loss unless you leave that block and then return to it.
Okay. Great
Which
catch.
you are
yeah.
never gonna do, because if you start at it, you can only go right or
Yeah.
down. And
Yeah.
if you go right, then the only way you can revisit it is by coming back from down. And why would you do that? So yeah. Yeah, I think I am fairly convinced they like this. Why do you have a bunch of new lines in the end?
Oh, sorry, I was struggling with your scrolling. You can delete them now. I've just unpinned following you, so it doesn't make
Okay.
a difference anymore.
So I'm gonna go right, and I'm gonna go down, and I'm gonna go left. When I am going right, I am adding 1 to x. When I am going down, I am adding 1 to y, and when I'm going left, I'm subtracting 1 from x. Just like that. Now I need to check whether this next state to explore makes sense. So there will be an if, And if the condition is satisfied, then I am going to put my states to explore. I will do that. What are the conditions? Well, my next stage, my next stage to explore, step remaining in direction, better be greater than 0 or greater than or equal. Let us think. We start at 3 steps and we are allowed 3 moves. So 3, 2, and 1. And then we are not allowed anymore. So it's greater than 0. And there is, and I'm going to put this later because it appears later here, but the coordinates also need to be in the board. So I would check that the next state to explore, coordinates at -1, and I can see that I will be using this often, so let's extract it. So if the x is greater than 0 and the x is less than the board length and the y is also fine. No, this shouldn't be greater than, it should be greater than or equal to 0. You wanted to rephrase this. Yeah.
Oh yeah, that's correcting a mistake that you had in a previous problem.
Indeed. And I will also want to check that this coordinate does not appear in the coordinates.
And you also need to check that you've got remaining ones. Oh, you've done that already?
Yes.
Cool. Good job.
Because I want to check occurrence, I think it may be advisable for me to not just have a list of coordinates, but have I know it sucks, but I'm going to change this. I will have coordinate and previous coordinates. And I will add a note here because I'm almost forgetting that I can prevent 180-degree turns. Actually, I don't need that because it will be in the list of visited steps. Yeah, it will just fall out.
Yeah, you don't need that.
Yeah, I don't need that. So previous coordinates, coordinate, and blah, blah, blah. So previous coordinates is going to be a set, and coordinate is going to be an object like that. So with that, we have to revisit everything we have written so far. For example, coordinate. I will rename that to my stage to explore coordinate.
Do you know if set is ordered? I think it is ordered as well.
Yes, the inclusion in the set is ordered, the inclusion in the map is ordered, and the inclusion of object keys, I think, is ordered as well. All right, so let's see. Including, I'm having a feeling that including the previous coordinates in the set here is going to blow things up, because if we visit the same stage and as we are turning around, the previous coordinates will be different. I feel like this is wrong. I'll put a fix me here. This is wrong. Or not this, but
It's not needed, maybe.
This is wrong. Remove some fields from state to explore. All right, so let's reread the program. We pop one of these states, we serialize it, we do the computation, that's all right. Then it doesn't like this, but why doesn't it like it? It seems like it's something it should like. Oh, I forgot to rename this. Now it likes that. Okay. And then that.
Do you need to exclude the previous coordinates then when you're stringifying it?
That's what I think. That's what this fix me is about. I will return to it because I don't want to think about it right now. I want to think about this new data structure that I'm coming up with.
Yes.
So for next state to explore, then I will need I guess I need to update my previous coordinates. So previous coordinates is a new set of a list of the state to explore previous coordinates and the coordinate that I'm in, which is my state to explore coordinate. And in all cases, I will just carry this and I will rename that. Oh, not only that. I will rename that, but I will also remove all the list situation that I had going. Okay.
That's much nicer. Good change.
Yeah, I think I like everything I see. So next, state to explore coordinates, none of that. So none of this as well. And this turns into next state to explore dot coordinate, like that. And then here I can check that it's not the case that my I want to say that it's not previous coordinates because that already includes the coordinate that we are about to go to. No, it does not. So it's not the case that previous coordinates includes or has.
Yeah. Yeah, nice.
Nice. And I have a fix me and I also have a to do. The to do being sort the states to explore by minimum accumulated heat loss. Nick is not a fan of JSON stringify. Me neither. In fact, there is a library I wrote called collections deep equals, which perhaps I should be using, but it's not super optimized and it's not the right name.
I also created a similar library.
Oh, really?
Which is called, well, similar vein, similar problems, which is like basically a memwise function, maybe similar to Lodash memwise, where it takes some arguments and then it will always produce the same output. So in this sense, when you're constructing the coordinates and things like that, when you construct it, if that one already exists, then it will return it. And I believe it does. Yeah, because that's kind of what you want as well. And then you will do all the like equality checking by using reference checking, which is just integer comparison, which is much better.
That's really cool. No, yeah, that's not the approach I took. I took the approach of changing the behavior of maps and sets.
Similar, like solving the similar problem, but in a totally different way. But yeah, explain the way yours works.
Mine works by changing the maps and sets. I create a new notion of maps and sets. I essentially inherit from the JavaScript map and the JavaScript set, and then I internally work so that I can find the equality of the keys using deep equals. But your approach is much smarter because it's not just for maps and sets. Everywhere in the program where you want to do any kind of equality, you can just use equality. You can just use reference equality. So I like your solution much better, and perhaps I should be using it.
It's nicer to an extent. I mean, there is object.freeze as well. I was going to say it only works to an extent because you can always mutate the values. But if you use object.freeze in conjunction with it, then yeah, it really can work in an immutable way.
Yeah, I didn't even know about object freeze. Or you can just by convention not mutate stuff. Fingers crossed.
For a script like this, it's like, yeah, it's not a big deal as well, yeah.
Okay, so I don't want to print the board anymore, and in fact, I really don't. And I don't need this anymore because I already have that, which kind of documents the thing. So let's see if everything that I wrote so far is sensible. I like how this undefined will just make this stuff happen correctly. Good call, that one. Steps remaining in direction 3, that's all right. It doesn't really matter. Accumulated heat loss is 0. States explored.
Are you doing the steps remaining in direction correctly? Like, have you got the right comparison? I can't remember what it was exactly. It was greater than 0. Okay, yeah, that's good.
Okay. Okay, so now it's time for me to address this fix me. I do not want to include the whole history in the states explored, because if I do, then this is always growing. Even as I find a state again, I have remembered the whole history, so this is growing, so I don't want that. So I'll now start being more careful about what I keep. So I will want to keep some of these and not others. Let's see. Previous coordinates is a no-go. The coordinate, I want to say yes. The direction, I think I want to say yes. The steps remaining in direction, I want to say yes as well. And accumulated heat loss, I want to say no. Yeah, I think that's what I want, because I want what is important for me to find cycles and deduplicate. But if it is the case that I'm visiting here because I have different accumulated heat losses, then by the nature of the sorting that you're proposing, I am good. So I don't want to have the history, but I want to have the immediate state of the world. The to-do needs to be inside the while loop. Okay, I moved the to-do here because that's where I want to sort. Okay, so I think that this makes it work. Then I want to stop visiting a node that I have already visited.
Yeah. I was going to say include the accumulated heat loss, but your explanation makes a lot of sense. So I agree.
Mm-hmm. 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 Then if I am at the end of the board, then that's our answer. Then the previous coordinates. Mm-hmm. Okay. All right, I can see that. Then the next state to explore, previous coordinates, accumulated heat loss, accumulated heat loss. Doesn't read all that well. This is better. Then I have already reviewed this, so I'm happy with that. Then let's review this real quick. Okay. Then the next state to explore, raining steps in direction, plus. Okay. All right. So at this point, we take our states to explore and sort. And this is going to be a compare function. So this is state to explore A, and this is state to explore B. And this is going to be a function. And I take that. But I want the minimum. Oh, yeah, that's right.
That's right.
That's right. Is that right?
Print the answer.
State is not defined. Where?
What line?
This line. And this is the state to explore. 223, it says.
Like the linter should catch that, really.
But actually, it's 102.
Enable TypeScript just to get that checking.
Yeah, maybe I should.
I guess you can have a setting to type check JavaScript. So you could enable that, and then you probably would have got that. But anyway,
Nick
so that's the right answer?
No, that's not the right answer. We have an answer that is too big. And Nick is probably telling us why, but let's see. You still need to pair that state with the total heat loss to be able to sort. So I assume it's just part of a combined value then. Pop takes off the last entry, so...
Oh, yeah, you need to unshift.
Thanks. That's silly. I want to pop 1 and it pops 3. So unshift will take no.
Oh, you need to shit it out. That's the way of remembering it.
Yeah, it's shift.
Do you know the way to remember it? Or did you understand the way?
The
way to remember which way round shift and pop is. Well, like pop is always easy to remember because you pop it off the end. I think anyway.
Mm-hmm.
But shift, the way to remember whether it's shift or unshift is you just remove the F.
That's a good one. Fortis is here. Hello. And
Hi, Fortis.
And I believe Nick is saying something that makes sense, that it may be faster for JavaScript to pop things off the end instead of shifting every element. So he's saying just invert the sort, which I'm happy to do.
That's nice.
And I recovered the pop. All right,
Cool.
104. That's still not right.
Is that because of the 2 in the beginning? Surely not.
That is because of the 2 in the beginning, because I am doing the accumulated hit loss here as I start. So how about
-2? But then you need to index it to be minus, yeah. Okay.
I feel dirty doing this.
Well, that's what this is about, writing dirty code.
How about we start with an undefined heat loss, and then if that makes me feel less dirty. So if the state to explore has an accumulated heat loss that is undefined, then 0, otherwise that. That makes me feel less dirty. So
Nice.
102. And now for the real Slim Shady. Please wait. Yeah, I thought that was gonna happen.
Oh, is it going crazy?
Oh, wait a second.
You finished?
It finished. Hooray!
Hey!
High five, everyone. High five, Nick. High five, Fossis.
I mean, it could be slow because of the sort, but probably not, you know. Like I was going to say, like normally you use a heap, but we're sorting every time. But I reckon that the sort probably uses Tim sort. So it's probably not a big deal.
Team sort?
Yeah.
Wow, what is that?
Most languages use Tim sort apparently, because most data is like partially sorted or sorted in chunks. And so it's based on, if you know that heuristic about the data, that it's not like randomly distributed, then it's much quicker to use that heuristic to improve the sorting algorithm.
Well, one thing that could speed things up is to not sort, but to insert in the right place. It could speed things up, it could not. I don't know. But we could do a binary search to find the place to insert, and then that's probably faster. But I assume that whatever sort they are using, if it's team sort or whatever, they will be really fast for partially sorted lists or for almost sorted lists.
Yeah.
Well, let's go to part 2 and see if we will need any of this. Maybe we have another easy day.
And also the bottleneck may well not be anything to do with sorting.
True. And I forgot about my tea and now it's cold.
Oh no.
The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade to ultra crucibles. Ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning. Once an ultra crucible, it seems like the ultra crucible is worse. I don't know why it's called ultra. It should be called the shift crucible.
Yeah, we don't like extremists in general.
Once an extra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn. So now it's the other way around. Once an ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. However, it will eventually start to get wobbly. An ultra crucible can move a maximum of 10 consecutive blocks without turning. So now instead of just having a maximum, we have a maximum and a minimum. In the above example, the ultra-crucible follows this path. And in this example, an ultra-crucible would incur a minimum possible heat loss of 94. Here's another example. Sadly, an ultra-crucible would need to take an unfortunate path like this one. This route causes the ultra-crucible to incur the minimum heat, blah, blah, blah. Okay. Directing the ultra-crucible from the lava pool to the machine parts factory, what is the least heat loss that can occur? If I understand this right, we got another easy day.
I don't understand what the part 2 is. Something about it needs to rotate. What's changing here? Sorry.
So if I understand this right, and we perhaps should double check before I start implementing my idea, but you know how we had the steps remaining in a direction? That changed. Now it's no longer 3 steps, it's 10.
Really?
But,
That's it?
Yeah, now we have 10 steps that we can take in a direction before we can turn. But not only that, not only we have a maximum number of steps that we are allowed to have, we have a minimum amount of steps that we must take. And more than that, when we arrive at the end, so at this point, we must have taken that minimum amount of steps in that direction, which is the number 4. We must have taken at least 4 steps. So that is my understanding. Do you want to go over the pros to double check, or do you want to start implementing this?
That makes sense.
Okay. So I will change the steps remaining in that direction to no, I will keep. And I will add what I call the
steps
required in direction. So that there are 4 steps that are required and 10 that are remaining. Right. Then I will want to put this in the serialization. Just by symmetry, I'm not really thinking about this too much. Then accumulated heat loss remains the same. The condition to stop needs to check the steps remaining, so I will add a condition that is less than or equal to 0. Less than or equal to 0, yeah, less than or equal to 0, or even 0. There's no point in going below 0, so I'll not allow this to be 0. Then I will compute the previous coordinates. That does not change. Then the next states to explore will change. So the steps remaining in direction, they will need to go up to 10, which at this point I could have a variable for this, but here we are. Then for the steps required in that direction, I will want to play a trick similar to this, so I guess I'm going to borrow this stuff. But what do I want to do really? If my previous direction matches the current direction, so if that's the case, then I guess I just say steps required in direction and the number 4 here. Yeah, I think I like this. Then a state is valid if...
Is it... Yeah. Did it say there was something about a special case for the last one? or not?
A special case for the last one, you say?
Just sorry, no, ignore me. Let's keep going with this because this makes a lot of sense. This is how I was imagining you would do it. This part, at least.
So, if my steps required in direction is greater than... Hang on, let me think about this. I think I want to rewrite this stuff. So, if my steps required in direction I want to do a math max of 0 and dash. So I never go below 0.
Yeah. Yeah. I mean, it's a good citizen of you.
Yeah.
Shouldn't matter for the algorithm, but yeah. This way we could use unsigned integers.
And here I will check if the steps required in direction are greater than 0. I need to be taking steps in that direction. So it is the case that for a state to be valid, either that or some other thing and my state to explore direction, which is the direction that I was going in, or not even that, is equal to the next state to explore direction. In other words, I'm going the same direction.
Yeah.
So let's recap. What I changed is that I am now introducing a steps required in the direction, which is tangent. We are making this even more constrained because now you can only start turning after 4 steps, but we are at the same time increasing the maximum allowed steps in the same direction. Are we making the state space bigger or smaller? Do you think that this program is going to run faster or more slowly than the previous one?
I think smaller.
At first I thought smaller, but now I'm thinking perhaps bigger because previously you had to take a turn on 3 steps. Now you only have to take a turn after 10 steps, so it seems like...
Does it depend on the difference between the remaining and the required? If that's bigger than the previous remaining. So what is it? It's 6 now. And before it was 4. So maybe it's adding 2 layers of complexity.
Yeah, I suppose the state's getting bigger. It stands to reason that they would ask for a harder problem on the second part.
But maybe just they're thinking harder implementation. Not for us. Well, not for you.
We'll see about that. Okay. I think I agree with this part.
Yeah, I like that if statement.
And then if the steps required in that direction is equal to 0, then I am allowed. It doesn't even matter if I am going in the same direction or not. But if I have to take steps in that direction, then I better have my previous direction equal to the direction that I want to take. Yeah, okay. Let's first run for the test example. Whoops. That does not print anything. But it could be the case that this board doesn't have a solution. Is it the same as the one above? Yes, indeed. In the example above, so it's the example starting at 2.
So
it
it's
should
still spinning?
It should get 94.
It's like not terminating? I didn't really see the terminal.
No, it's just not speeding anything. So I don't think we are ever reaching the lower right of the board.
Oh, so it's exiting?
Yeah, it is just terminating. Wasn't it supposed to? Not that fast.
Oh, is it because it's just like it's reaching there, but then it's reaching there in an invalid state or something?
Yeah. But I suppose we are not even getting here. I suppose that there is some other problem in the code. Let us take a look at what changed between parts 1 and 2.
It's an interesting...
So what changed
I would just
is that...
check if it's running.
No, it's not running. It finished immediately.
Or just like... But just check where it's getting. I would just like start logging stuff. But this is also a cool way of doing it.
Ah, okay. So steps required in direction. I agree with that. There is an extra condition to stop, which is that the steps required in direction must be 0, and I agree with that. Then we are adding the steps required in direction. If I am going up, and I was going up, I'm still going up, then I want to take 1 out of that. That seems okay. Stops remaining in direction is now 10, and then that's pretty much just copy and paste. Then over here, maybe the problem is here. We are never making this true, so it's just never pushing more stuff to the next state to explore. Yeah, that could be the case. So I'm blaming this. Let's review this.
It's because your direction starts out as undefined. So that condition is never true on the first iteration.
So it is this that is not satisfied. So my state to explore could be undefined. So how about we use the knowledge coalescing operator here?
Yeah, lovely. Beautiful.
That's silly. But I'll take it. No, that's not only that.
Did it just exit straight away?
Yeah, it's still exiting straight away. So I'm still blaming this if. And let's see what Nick has to say, because he's an insightful person. You want a priority queue instead of sourcing the list. Who needs constraints? Magic numbers are the way. I agree. We can go below 0 now, so either do less than or equal to 0 or check, I guess that's the math max that I did. If you had just tracked the amounts of steps taken in the current direction, you could evaluate it against the min max constraints, shrinking your state a bit, but it won't be an issue. I don't think it would. I don't think it would shrink the number of states. I think that I agree with you. My representation is a bit silly because I am effectively tracking the number of steps twice, as revealed by this happening twice. But whatever. But I don't think it would impact the state space.
I agree with that.
Okay, so let's review this because there's still something happening. my state direction to begin with is undefined. Well, in those scenarios, I think it is worth... I'm still suspicious of this. Let's look at it. We are doing work.
So we just never get to the bottom right. If you undo your knowledge coalescing, was it exiting? Out of curiosity, like, did we? It does make sense that we needed to do that.
Aha! You caught one mistake. Now catch the other mistake. Nick saying, want the answer? No, thanks. Not right now. But let's try this example and see why they gave this example to begin with. Because I'm suspicious. Why would they give this example? There is something tricky. There is some edge case that we are not considering. So let's see. We are not finishing, not even in that example. But perhaps we could print the coordinates and then see where we are going.
Was there something about, were the only changes to the constraints the required in and the remaining? There wasn't something about a special case for the last node, was there, in the pros?
I suppose there was. Now you need to get there with steps required in that direction equals to 0. But let's see if we get here at least. We don't. That is odd. How come? Can you reason about why it wouldn't work?
I mean, I
guess that's what we are doing.
There are some. I can imagine that there are some unreachable nodes because you have to take 4 steps so you can overshoot in one direction or another. But I would imagine that they've set it up so that you can always reach the nodes. So maybe there's like a mistake in an off by 1 somewhere, maybe.
Can you say that again, please? Because I was making my camera turn on again.
Well, I can imagine that if you're forced to make 4 steps, but like a certain number of steps in one direction and a certain number in another direction, it could happen that you could never reach that bottom node in a valid state, right?
Yeah. Yeah, I think that is the case. I think that there are some nodes that you will not be able to reach. But yeah, I can see. I guess this example is just to demonstrate that you would like to do this, but you must not because of the constraints on number of steps. So you have to go through the 9s. I guess that's all they're trying to say here in this example. And because you have to go through the 9s, you want to go through the 9s the least you can. So you want to go through the ones the most you can. So they do 1, 2, 3, 4, 5, 6, 7, 8. What? Oh, because you need the 4 in the end.
I wonder if this is correct. For the very first. Well, there's 2 things which come to mind. Is this going to be correct for the very first one where the direction is undefined? I guess because direction is undefined, then it will be 4 for for both down and right.
Yeah.
And that is correct.
Yeah. And Nick is still on the chat disagreeing with us. So let's try and understand why. He's saying everything is reachable. With the game rules, you can reach every position on the board. And then he's again saying incorrect. You, David, and I are incorrect. You can make a path to every point on the board. So that reveals that I misunderstood the problem and I need to reread it. Because if I understand it right, well, I guess technically speaking, you are able to reach every point on the board, but you have to go around the board a lot to get there, right?
No, I take that back. You are able to reach every point on the board. I was thinking in my mind that you have to have completed all your required steps when you finish on any point. And I think that you can't always finish all your required steps when you finish in the bottom right of the board. Like, I don't think that that's always achievable. Sure, but you could definitely reach there in any configuration. But I'm sure I could create a board where you can't get to the bottom right and have finished all the required steps.
Yeah, I guess, for instance, in this example, if we have taken all the ones we can, because we stopped at 8, but we could have gone up to 10, then go down, we wouldn't reach this end node having taken 4 steps.
Or more trivially, you could have a board of just 2 characters and then say the minimum steps is 4, and then obviously you can never reach them.
Yeah. Yeah, so now we are still working with this board, which should give us an answer of 71, and we are not getting any answer at all. And Nick knows what the problem is. So it's not a problem of performance, it's a problem of correctness, which is very interesting to me. I'm thinking that maybe we could just rework this and perhaps we will fix the bug along the way. We could just keep how many steps we have taken in that direction and then do like greater than 4, less than 10 and stuff like that. Do you want to go that route?
Well, that's where the light is, and it will be nicer code to read. It will be less code. So, and it shouldn't take too long.
And Nick is saying, so what is preventing you from taking that path? What is preventing me from taking this path? I don't see it. So, yeah, I'll do the thing. So, steps in direction. And I'll start with 0 steps in that direction. Then, and I already addressed this fix me. I even addressed it in part 1. I'm going to revisit part 1 to remove my fix me. Now, will I want to keep this? I suppose yes. Because that's what worked for us so far.
Mm-hmm.
And besides, it influences whether we'll be able to take turns or not. This I agree with, that I agree with, this I only allow to end if I have taken 4 steps, at least.
Mm-hmm.
Then
you could log if you get there and only break. Well, whatever. I'm just curious if we ever get there. And
since we are doing this pass on the program, I'm gonna have variables for my magic variables. So minimum steps before turn 4. Maximum steps in direction 10. And you were trying to say something. What were you trying to say?
Yeah, I was just saying I'll create a constants file so that we can really refactor.
And Nick is saying, if you want, I can tell you exactly where the line, where the issue is. Please don't. Please don't spoil it for us. It's very nice of you to offer, and I know you must be on like, oh no! But let us take our time. We'll get there. We'll get there.
Nick, you can message me privately with the line number.
No. Okay, so the number 4 appears in some part of the program here. And this is our minimum steps before a turn. That is right? This is correct.
What are we checking here? The minimum step, the steps in the direction must be greater than or equal to, that makes sense.
Yeah, okay. And then this is still a valid thing to say, and then this is going to change. It's going to be steps in direction.
If this doesn't work, by the way, I'd like to reread the description again.
Okay. So if I am going in the same direction, then that. So if I am going the same direction as I was, then I will add 1. Otherwise, 0. And then I will copy this and paste. Or I guess I will copy this and paste.
Yeah.
And paste here and there. Like that. And then I will go up. And then I will get my direction, and then I will go down, and I will paste my direction.
Nice.
Excellent. So now the conditions need to be different. The boundaries of the board remain. The fact that we don't want to run into a coordinate that we have seen, that remains. Then there will be some undefined situation here, but that now it's okay, because the undefined will be like undefined is equal to up, no, so 0 steps in that direction. Or 1. Should it be 1? Should it be 1? I think it should be 1. I think it should be 1. I'm going to change this into a 1. There, it's 1.
Yeah. That might be the fix.
Then
it might be in the default value in the ternaries.
Then I'm just going to check that the number of steps in the direction.
This is where you want the Python syntax, isn't it?
Yeah. Well, not quite, because I still have to factor in this stuff.
Oh, yeah.
So I guess I'll just start from scratch here. So what I'm interested in is if I have, first of all, less than the allowed. So that's easy enough. Next, state to explore. Steps in direction needs to be less than the maximum steps in direction. Less than or equal? I don't know. Keep watching and we'll figure out. And I'll put this above. If my state to explore direction is equal to or is different from in other words, I am turning and minimum steps before turn. Is this a less than or equal? I don't know. Keep watching. We will find out. There. No.
You don't have steps remaining anymore.
This
line is not needed.
Yeah. I find it curious that the minimum steps in direction only appeared in one place. But I guess that's right.
You mean the minimum or the maximum?
Yeah, the maximum. This variable only appears in one place. But I guess that's right. Yeah, I think I agree with that. And then this, and then that. Yeah, that needs to appear into places.
Hold on. The state to explore. Doesn't the...
I'm changing things here for cosmetics. I really have a hard time with this off by 1 situation. I don't know if this should be a 0 or a 1. I don't know if this should be a less than or less than or equal. I don't know about that one, and I don't know about this one either. So,
I'm not sure I agree with this.
Let's see where your cursor is. You don't agree with what?
So here you're saying, and it always changes direction.
Yeah, that is not correct. So what I want to say is that what I want to say, let's see, is either I am going in the same direction or I am changing directions and I have taken the minimum steps there. Okay. And
so if you're going in the same direction, you need to check 2 things. One, that you haven't passed the maximum in the current direction. No, you just need to check if you haven't past the maximum. Yeah. And if you're not changing, then you need to check that you haven't satisfied the minimum.
Well, if you are changing, you need to check that you can satisfy the minimum.
Yeah. So if
you're not going in the same direction.
Yeah, exactly. Yeah.
Okay, so now my real problem is thinking about all these 1s and 0s and less than or equal, and I want to cry. It still doesn't output anything. So,
but hold on, did you fix this?
What is there something that you see that is incorrect?
Well, this is outside of the condition, right?
Yeah. But it should be.
Oh, okay. Well, then maybe I just need to read it again. But that's not how I was thinking of doing like a ternary type thing. But if maybe this does cover it, I'll have to reread it to verify that. So this is like, if we're going in the same direction, either we're going in the same direction or we're not going in the same direction. And I guess we don't need to check that. Or we're not going in the same direction and we've satisfied. Yeah.
Yeah.
Okay. Yeah.
So I will leave some fix me's for the places where there are less than or equals situations that we need to think. Oops, I'm still following your cursor, which is confusing. And there is more here, because I don't know if this should be a 0 or a 1. But even with the problem of off by 1s, we should be getting the wrong counts, but we should be getting to the end of the board. We are still not getting to the end of the board. So whatever problem we had before, it still exists. We are not getting to the end of the board. Not even in this very simple input. What is preventing?
Maybe we can just print the nodes that we're exploring. See if that gives us some insight.
Okay. I guess we can do that. about there, so we don't, whatever, just put it here. We're just in the beginning. We're not even exploring a second stage.
Okay, so there's something with the direction undefined.
This if is still the culprit. There is something that doesn't allow us to get in here. Let's see. I will console log hi, and I will console log hello. And my claim is that we will see a bunch of highs and no hellos in the console. Yeah.
What I mean,
why would it be? Let's explore this step by step. So, what is...
Yeah.
And
okay.
Ivasler is on the chat. Hello. Priority queue, at least in Python, has trouble with updating priority. Also, for directions, you only need horizontal or vertical information. True, because if you're going horizontally, like to the right, then your left is already on the list of visited nodes or coordinates. But so, what is our next state to explore? For instance, this one, the first one. The next state to explore coordinate x is 0. Is it greater than or equal to 0? Yes. Our next state to explore coordinate x is less than the board length. Yes, it's 0. Is this the case? -1. So yeah, perhaps that's not a good example because this is invalid. So let's get an example that is valid. For instance, going to the right. So the x is still greater than or equal to 0. It's still less than the board length. Then the y is greater than or equal to 0. It's less than the board length. And the previous coordinates has the coordinate that I'm about to explore. No, it does not. So here, this is where things are going to go bad. So is my state to explore equal to my next state to explore?
Can I suggest we turn this into a ternary? Might be easier to reason about, or unless you're happy with this. Maybe you're happy.
No, I think that the undefined may come into play here. So is my state to explore direction equal to my next state to explore? Undefined is equal to right. No, it's not. So
I guess we don't need to consider any of this if the direction is undefined.
So what you're saying is that I should do maybe something like this.
No, I would do it like, well, probably that would work. But like, I was thinking,
No, don't touch that. I think that this makes sense. If the state to explore direction is undefined, it means that we don't have to care about anything else. We don't have to care about any of that. It is the case that we can consider this as a valid state to explore.
Yeah. This is probably what we fixed the first time around.
So now we will get more states to explore. Now we will get a wall of text. Not even. Let's do this. Let's find where are our console logs. There is this and there is that. Now we should see some hellos on the terminal. And I will process exit. I will try to process exit if I can. Process.exit. Nope, exit. Ah, there you go. Just because I don't want to blow up your terminal. Okay, we see hello. So we are getting in. Okay. So I will remove some of the junk and let the program run. And still doesn't get us there. So this is difficult. It's more difficult than I'm expecting. It's not a difficult problem, but
it's difficult to debug.
The problem is it's not difficult. It's not a difficult problem. It's not difficult to debug. We made a mistake somewhere that Nick is screaming at the screen about. And it's probably like a minus that should be a plus or an X that should be a Y, something like that.
We still didn't explore your off by ones.
But that shouldn't be the problem, right? We should be getting the wrong answer, but we should be getting unanswered. No answer, there is a bug, a very silly bug somewhere.
This does sort in place, doesn't it? Yeah, it does.
Yeah. Nick is saying no, there's something more fundamental than that. So let's go back to the problem. Part 2. The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade the ultra crucibles. Okay, ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning. Once an ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. So my understanding is that it needs to take that amount of steps before it can turn. And it needs to take that amount of steps before it can stop at the end. And of course, there is something wrong about my less thans, because here I have less than or equal, and here I have less than. So for sure, this is wrong. But we should still be getting an answer.
Well, you might be reaching the end, but it might just not be. It might be an off by 1. So I think if you removed that first less than or equal, then do you see what I mean? It might not be printing.
You are saying that we can comment this and get a result. And that's not the case.
Okay. Well, at least that an off by 1 could cause that issue, though.
I don't think so. An off by 1 would get us a different path and therefore a different result, but it should still get to the end.
Yeah, that's true.
Well, this board is kind of small. We can only take 4 steps in a direction, so an off by 1 could be the problem. But it's not. But now I kind of goofed up the input, didn't I? Okay. Let's do this. So we will not be beaten by an off by 1. And yeah, let's continue with our reading. However, it will eventually start to get wobbly. An ultra crucible can move a maximum of 10 consecutive blocks without turning. So it's the same as before. A crucible can move a maximum, I guess, of 3 blocks. An ultra crucible can move a maximum of 10. I guess. In the above example, an ultra crucible could follow this path to minimize heat loss, blah, and blah, blah, blah. Sadly, an ultra crucible would need to take an unfortunate path like this route, blah, blah, blah. I don't see any problem in our understanding of the problem. Do you see a problem in the understanding of the problem?
Oh, no.
Okay. So, it must be a problem in the way that we implemented our interpretation. And what I want to see is why we are stopping. Or maybe even where we are stopping. What is an easy way for us to debug where we are stopping? So I want to find when I reach the end of the line, what made me reach the end of the line. While we think about this, I will try and fix my camera once again.
I mean, I would just I wouldn't worry about my terminal and just start printing the nodes that we are exploring and see if we can work out what we think is wrong.
Well, whatever is wrong must be wrong in this conditional. So I want to read it one more time after having read the problem again. Are we in the board? Okay. That part I trust because it is exactly the same as the previous problem. This I also trust because it's exactly the same as the previous problem. This I may not trust so much, but I don't trust the less than or equal versus less than or the less than versus less than or equal. That part I absolutely distrust. It's probably obviously wrong, but it's not only that. I could have a less than or greater than situation going. But I kind of believe it, that the steps in direction needs to be less than the maximum. So I kind of trust this one. And if this was wrong, then we wouldn't take even the first step, which we are taking the first step because we saw hello on the terminal. Yeah, it was in the past, but we saw it. So that part I trust. Then let's go over this chunk. So either my direction is undefined, or my direction is the same as before. And then I don't need to check the minimum. And why do I call it minimum steps before turn? I should say minimum steps in direction, right? Just to match.
Mm-hmm.
I'm going in the same direction, or I am trying to take a turn and I have taken already as many steps as I need. So I have taken more than the minimum. Yeah, I believe that. That seems feasible. And I think this is going to be a wall of text that doesn't make any sense to me. And so it is. But let's at least see if any of those reaches the end of the board, which would be, yeah, something like 2 large numbers. So coordinates should be 2 large numbers. Are we even getting somewhere in the neighborhood? And I don't see anything in the neighborhood. It seems like we are only going down once.
Are we never going down?
Or going to the right, I mean, actually.
Yeah. Well, no, we're going down, but yeah, never going.
We are never going to the right.
Left.
X never increases enough. Well, it increases here. And no, this is, it's difficult for me to visualize what's going on. Nick is saying, so now you have an additional issue that did not exist for part 1 code to add to the mystery, to the misery, to add to the misery. The code should give an answer with that min condition removed for the end step, though. Although it might not be the correct path, it should get there. Yeah, that's what you said before, David. And it's still not outputting anything. There's something fundamental about our if here that is making us not get to the end of the path. So how about we don't get the wall of text?
Why is it?
How about we don't add this? I have a proposal that is just ballistic, which is we don't check the number of steps in the end, and we don't check the number of steps ever. We just don't check the number of steps. Forget about number of steps. We should be able to get to the end of the board, right? And we are. Now, how about we care about the number of steps for the problem as in part 1. And we still get to the end of the board. And how about we introduce the fact that this fact. So I guess I will take it out of there and put it in parentheses here and an and in the end. And we don't anymore. But that's because there are other things that could be happening. So, or this. Or that. One of these must be true. Okay, and now...
I don't like it that we're comparing either it is equals or it's not equal. But yeah.
You wish to just write it like that, right?
Well, I think it just feels like we should only really need to compare
which amounts to the same. And that is going to make us not get to the end anymore. What is wrong in this line? We found. Nick said that he could point at the line. We found the line. It's line 291. Why is it wrong? Why is this giving us a hard time? I'll move this here.
Because we're comparing the next state to explore. Isn't it state to explore that we need to be checking on line 292?
No. We are checking the validity of the next state to push it to the states to explore.
Yeah, but the next state, steps and direction is going to be different to we're turning from our current state. So we're checking the minimum steps in the previous state. Was it okay to change?
Interesting. So what you're saying is this. So could we have taken the turn? And then we get to the end. That's good. That's great. Now we are just dealing with the off by ones.
Hopefully.
And there are two of them here. And then... can we even introduce this back? We can. That's great.
Okay. That's promising.
And if we get this... then we don't get to the end of them more. But that's all right. That's probably the off by ones that we need to fix. So now we really need to think, because at least for me, this is going to be wildly complicated. Great catch, by the way. Great catch with this.
Thanks.
Good job. So
how are we thinking about steps and direction?
Nick is saying, I think it was correct before that you compare against the next. The issue is elsewhere.
Oh.
No. I think that now the issue is just the less than or equal. The change is wrong, Nick is saying. Why?
Because the steps in direction are going to be zeroed out, aren't they?
Yeah, the next stage will be like this. And then we would never be able to take the turn. So you determine the amount of moves in your next.
That's why we were always going right to the end of the right line and right to the bottom.
Yeah. No, I don't know, Nick. I think that this is what we want. I think we want to check if we are going in the same direction.
Mm-hmm.
That's no, wait a second. From the top, people, from the top. How do I determine that the next state to explore is valid? It's either because we are right in the beginning. That's trivial. Okay. Or we are going in the same direction as before. No, that doesn't sound right. Or we are going in the same direction as before. Oh, and then in that case, we are right in the beginning. You're just writing down what I'm saying. And we are going in the same direction as before. So we have not taken a turn. So we don't need to check that we have already fulfilled the requirement to be able to take a turn. Or we want to check that we have fulfilled the requirement. What is the requirement? The minimum amount of steps, blah, blah, blah. The requirement is that we have taken at least that amount of steps, and that is how many steps we have already taken. I really think that David is right on this one. And besides, the code executed and it did the right thing. So I'm very confident that this is right.
Mm-hmm.
And but you need to validate the sort. Wait, what? You need to validate the sort you will take, not what. You need to validate the step you will take, not what you already have.
But we are validating the step that we're going to take.
We are validating the step that we are going to take by looking at how many steps in that direction we have taken. And Nick is pretty sure that we are both wrong, and we both are pretty sure that Nick is wrong. Let's proceed with that and come back to it, okay? Because I think that now we are only wrong with the off by ones, because this big board gives an answer. And now for the smaller board, we are expecting to see 71. So if I turn this into a less than, or if I turn this into a less than, then it becomes more restrictive, which I don't want to do because currently the code is not getting to the end. If I turn this into something more permissible, then we get 71, which is the correct answer. And if I turn this into something more permissive, then I still get 71. But I think that I like the ones here. Let's see. Do I like the ones? Because the ones here are going to determine everything else. How many steps have we taken in the up direction? Well, we are taking one step up. This direction really is like the previous direction, right?
What are we looking at here? We're saying, so we're saying we're going up. The last one was saying it was going up.
Yeah, it's more like I arrived at this block coming up. So it's like more like the previous direction. That's all right. I'll not rename it. So I'm going up. So my initial number of steps in that direction is 1. Because I have already taken 1 step in that direction. So I like this 1. I'm going to keep it. And in light of this 1, we have to really think hard about this less than or equals. Nick is saying I'll leave you to it. You can compare to your part 1 code, which also checked next, not current, because you are trying to filter valid moves to make, so those values need to be correct. I'll drop it. But you see, in part 1, we were using a different approach in which let's see part 1. Let's get to the bottom of this.
We were doing remaining, which is not about minimum.
Well, that, but also, how come we are checking this, right? That must be wrong. If this is wrong, that's wrong. So I suppose that this is wrong. We're still getting 71. Part 1 was right. Well, there is a difference. In that here we are counting the number of steps. Perhaps we shouldn't have done this refactoring because it's adding to the confusion. But on the left, part 1, we are thinking of steps remaining. And in part 2, we are thinking of steps already taken. But apart from renaming the variable, we didn't do much. And it is true that here we were using the next step, the next. No, we were not. We were using the state to explore, not the next state to explore. No, this is the new code. Oh, shucks. And here we were using the next state to explore. How come I'm convinced that part 1 is right and part 2 is right and they are doing different things?
Because we I think it's just like steps remaining in direction, maybe. I don't know, I'm having a hard time thinking about it, but I feel confident in part 2 for now.
Sometimes equals, so it darn. Nick is saying the issue is not in the min max part. Sometimes doesn't even matter for solving the issue you have. Okay, so the issue is not the min max part, so it doesn't even matter for solving the issue you have. The issue is not in the min max part. What would be the min max part? What is the min max part?
I think he's maybe talking about like off by ones.
And
I think maybe we're looking at the like that condition as the like primary issue with our code, right?
Oh, that's so funny because this problem is easy. Or at least the way that we will see if this will even be fast enough to solve the big puzzle. But this problem is easy. It's not a difficult puzzle. And yet my brain is fried, I guess, because I cannot make sense of it. The left is different from right, and I think both are correct. It's just like, oh.
Yeah, I'm finding it hard to think about like part 1 and part 2 implementations at the same time. I don't know if we need to do that.
But I would like to understand why this is right, because it is true that the next state to explore on the left is already taking in account whether we are in the same direction or not. If we are in the same direction, then it subtracts 1, and if we are not, then it resets. But the problem really is that if it resets, then we would not be able to answer the question of, did we take a minimum amount of steps yet? So this new strategy is fundamentally different in that way. It's putting the problem upside down, and here we are overwriting the steps in direction.
Yeah, it's different. We're keeping track of different things because we're only updating the steps in remaining in direction if it's in the same direction in the first problem.
Yeah, but the condition here is the same. So
yeah,
this is really disorienting for me.
Yeah, for me too.
Wow, this problem is so easy, and at the same time, I'm having such a hard time with it. But Nick is going to bed, but before he went, he said, exactly, David. So it seems like you understood something that I still don't understand. Oh, and he's saying you can revisit it tomorrow if you want. Let me know if you want the answer. So it seems like there is yet another thing, or maybe just the thing that Nick was talking about, we still haven't figured out. All right. Well, thanks for all the help so far, Nick, and I'll see you tomorrow.
See you tomorrow, Nick.
Have a good night.
Didn't we get the right answer, Leandro? Didn't we get 71?
We got the right answer, but we are still just dealing with the minimal board. I guess we could go to the bigger one to see. But what is this comment? Because when you wrote this, Nick said exactly, David. So what is this about?
No, I was just thinking of like I still find this hard to read. And for me, it would be simpler to read if we had this as variables, like all of this and can change direction or can keep going kind of thing. You know what I mean? Like I would just extract it into variables and then we can think about the variables individually. But I don't think that the issue is if we want to like keep thinking about this condition, because I feel like we got quite far with it and it seems to be working well.
Okay. So okay.
But that's maybe how I would refactor it. Maybe I'll do that like tomorrow or something when I have more time.
No, first I have to try and think of what could be going wrong besides the less than or equals and stuff like that, the off by ones. What could be Nick talking about? What are we misunderstanding about the problem? Should we reread the problem again? No, I'm fairly confident I understand the pros.
Could we try running on the real input?
Yeah, we could do that. But let's just take a second to read these things and see if we like them. We need to take 4 steps. How many steps? Okay. The problem I have in understanding the pros is when it comes to the less than or equals is when it says like 4 moves, is it inclusive or not? That's my question. So let's take a second to read this. It can move a maximum of 10 steps. So it can move, but we don't see an example of that here, I don't think. Maybe this 1, 2, 3, 4, 5, 6, 7, 8. So we don't see an example of that. But what I think it's saying is that we could have 10 down arrows in a row.
Mm-hmm.
Inclusive. So 10 down arrows. And even in this drawing, the arrows, they represent exactly like we represent stuff, which is how did I arrive here? Direction in this drawing represents how did I arrive here. So we should be able to see 10 arrows in a row. Are we able to see 10 arrows in a row given this line? The maximum steps in direction is the number 10. And when I do this first step in the down direction, so now I'm looking at this, right? I was going to the right, and I'm going down now. So my state to explore is down. No, it's not. So now it's 1. So I counted 1 because I am going down.
Is it this thing about like entry direction and exit direction, like the way they're thinking about it? Because the way they draw it is not maybe how we're representing it.
Mm-hmm. Can you explain that in a different way for me?
So you see how it's drawn on the screen there? You see the one which you've selected.
Mm-hmm.
If you select the one above that.
Mm-hmm.
Yeah. So you see that like its direction is pointing right.
Mm-hmm.
But actually it's in our code, I think we would say the direction is down.
No. This is the direction that we took to get there. So for instance, when we are creating new state, it's kind of, yes, the previous direction. That's why I said that perhaps we should even rename this variable, because it is the direction that we took when we arrived at this block. So we are representing this exactly in the same way as they are drawing. And we can take 10 steps in a row. So it means that in this case, the number of steps in direction is less than or equal to the maximum, because we start with 1.
Mm-hmm.
Or maybe not, because we are using the previous state when checking this.
Is that why?
Why are we using the previous state when checking this? Here, we could be using this stage, the next stage.
Yeah.
Because there is no problem with like we have just reset things. So I think that this reads about right. And it does not run into the whole, what we are now calling the Nick problem. It doesn't run into the Nick problem. But this runs into the Nick problem. We solved this by doing that, and we were fairly convinced that this is right, but it has the Nick problem. And I still think that this is right, though. But then it's very puzzling to me that this is right and this is right, and they don't read the same, but they are both right at the same time.
Does it still get 71?
It does. Okay, and when you say the 4, is the 4 inclusive or not? It has to move a minimum of 4 blocks. So it must see 4 arrows, and we are counting arrows. So what we really want to know is, I'm about to go to the right. Have I seen 4 arrows? So now I want to ask a question about the past. And that is the right thing. And yeah, that is less than or equals. I think that this is correct. Is there still any other fix me? Yes, here. And by the same logic, that is the case. Okay, so now we are getting a 71 that I'm confident about, and I want to see what happens with the other input. And that gets us a 94, which is the right answer.
Okay.
Okay.
I think we got this, Leandro.
So maybe the Nick problem was a Nick problem and not a David and Leandro problem?
Maybe.
Evasler is saying, it is inclusive. When you change direction, you move by 4, and you can continue in the same direction for 6 more steps. Mm-hmm. Yeah. Okay. So, the program is running, and if we have to make it faster, what can we do?
I had some good ideas earlier, which I didn't say, but I can't remember now. We're just traversing. There's also like the JSON stringify stuff, like maybe that's slow or something. Or like maybe. Yeah, but the fact that we're sorting things, I think that's pretty optimal.
Well, there is one thing that we could do that would make things a bit faster, marginally. When we decide that we are going to change directions, we need to take at least 4 steps. But we are taking these 4 steps by going around the loop, which is more costly because we put things in sets, we do sorts, and blah, blah, blah. And all of that is just to find right on the next goal that, oh, but we cannot change directions again. Oh, we cannot change directions again. Oh, we cannot change directions. So we are doing a lot of work just to find out that again and again that we need to change directions. What we could do is, if I decide to take a turn, oh, I have an answer. If I decide to take a turn, I could just take the 4 steps, add all the hit losses along the way, and I don't need any of that. That's the right answer. Woohoo! Good job, David. Good job, Nick, Evasler, and Fotis. Now.
And you.
Thank you. And I think that the Nick problem was a Nick problem.
I think he might have been trolling us. I think he's been doing this all along with his simple for loops. He's been getting us to. He just wants to see us. He likes seeing us debug. I think.
Now, I know that this took us more than 2 hours to do, but I would still say that this was an easy problem. I think that perhaps this was easier than the day 10 in which we had to find the area inside the maze. Because to find the area inside the maze, there was more like logic and drawing and mistakes and all of that. This was just like, it was not an off by 1 really, but it was like kind of an off by 1 if you think of the time axis. Because we were looking at the next state when we should have been looking at this state. Yeah. So I don't find that this problem is difficult or challenging. So I'm surprised because I was expecting the weekend to be more challenging.
I think we might be trying to second guess how they've designed it, and probably they sort of graded them more or less on. I guess that like they've got a lot of things at play here because they've got the story to account for and the ASCII art, and then they've got to get people to do them, and then they've got to like make it all come together and the problems working together and stuff. So like, I don't know how easy it is for them to plan for it also to work on the weekends and stuff. I think that's a guess. But also I think that like, you know, some of these problems, they do have gotchas. Like this problem has a starting number, which could have caught us out, right? If you hadn't read that little line, I probably would have spent hours debugging that. Or the double backslash, that could have caught people out for a very long time. You know, there are like these little things which can make simple problems very, very tricky.
Yeah. So in summary, what we have learned is that if it wasn't for this, we would probably have been out of here 1 hour ago, right?
Yeah, something like that.
And why was the previous code okay? Because here we are checking only when we have been in that direction for a long time. While here we are checking
we're about to change.
That we are about to change, yeah. Okay, well, whatever. I want to put this to rest, but I do want to take a peek at the Reddit.
Yeah, that's always fun. I may look at yesterday's code versus today's code with fresh eyes and be able to have a clearer way of resolving it. But for now, let's just look at.
Finally, a path traversal problem. We will use my prepared A* implementation and be done in 10 minutes.
Mhm.
People are giving up on day 17.
Really?
Huh. Today was the hardest day yet, judging by my rank as an European who doesn't wake up early to the problem. I don't know. I would say that day 8 was like at least 2 orders of magnitude harder than every other day combined. If you put all of Advent of Code
Although
combined,
if you
it's
have
day 8 is harder.
Yeah. Although, if you've never implemented Dijkstra, although to be fair, if you like, you may have implemented BFS, and that's flood filling, right? And stuff around that, or you might have thought of a really clever solution to day 8, which doesn't involve flood filling or something like that. Like I heard people who just like
No. You're saying day 10 then. The maze.
which one was day 8?
Day 8 is the graph traversal, and you have to find cycles and you use LCM. That one is orders of magnitude harder than everything else we've done.
I don't think so, because like as soon as you it's only harder when you don't spot that there's like that offset thing and there's like LCM, because LCM was the first thing which came to us. And then it was just like we didn't realize this trick about the offsets matching up and lining up and inspecting the data.
Yeah.
So like
it took me like one whole afternoon after we have worked on the problem. I think for 3 days, it took me a whole afternoon of staring at the inputs and trying to find patterns.
Yes, but like, I don't know, it's kind of easy when you know how. Whereas like a problem like day 10 is like as soon as you saw that pattern, like it's easy for you to implement, right? But like day 10, even if you know what the thing is, it can be tricky to implement it. Like there are like gotchas and stuff.
Yeah, day 10 is more code. Day 8 is very little code, but it, at least for me, took many hours and a lot of insight. And like even Aline and I, we were like, oh, and maybe there is a reason why these are co-primes, and what if we take the factorial and whatever. It was just like mathematically super complicated and super tricky, because a lot of the information you needed to solve the problem was not in the problem statement. It was in the inputs. So the problem statement was kind of guiding you to do the more generic problem with the Chinese reminder theorem. And even the Chinese reminder theorem only works if there are some properties of the inputs, like if some of them are co-primes or whatever. So the more general problem is really complicated. And they were trying to hint at like, oh, you need to solve that, or you need to figure out the pattern. So it was a very difficult day. It was about the same level as the problem that we were working on for the Google foobar thing.
Yes, especially if you didn't spot the input issue, right?
No, I mean the general problem. The general problem is really tricky.
100%.
And then the more specific case, you have to spend a lot of time to figure out that you are in the more specific case. So
yeah, and I think they're different, and they're like different difficulties in different ways. But I think you are right. In a certain facet, it's a very tricky one, the one you said. But like, for example, you remember the one with the focal lengths that you did, and you like smashed it out really quickly? That one was very easy, but it was definitely the hardest to read. Like advent of reading comprehension, it's like the hardest problem.
Well, and I wasn't careful about one thing. They said hash map in the definition of the problem, and then I was working out case by case and blah, blah, blah. I could just have read, it's a hash map. Just use a hash map. There is a hash map in JavaScript. It's called map. And then I kind of re-implemented it from scratch by looking at the labels and stuff. It could have been even simpler.
Yeah. Well, isn't that the same as a sparse array though? You didn't need a hash map because like you allocated all the boxes.
No, I was not even thinking about that. I was thinking about inside a box, you do all that. You remove or you replace, and you have to check if the thing is there. So you check for containment.
Oh, you just put a hash map inside there.
Yeah. So each box could have been a hash map.
Yeah.
Many people did that
100%.
in the subreddit, and then the problem is very easy because there is very little code to write.
Maps, and then get over yourself.
It's I would use an array of hash maps. Yeah, an array of hash maps I think is the way to go. But so that problem was perhaps difficult to read, but not difficult to implement. And many people in the subreddit were saying like it was difficult to understand.
Yeah.
But not to implement. And the one today, it was easy to understand, and I would even say easy to implement. Of course, we goofed up, but it was not that difficult of a code to write. And it is even...
I think it was like harder than yesterday's though.
Yeah.
Yeah.
But the idea is pretty much the same. Like there is a work list, and then you push to the work list, and blah, blah, blah. All right, just like yesterday, using complex numbers to store positions to handle the movement constraints, most solutions check whether we are allowed to move one step in their directions. Instead, we simply do the left turn and move mean steps. Turn left and move mean steps plus 1. Turn right as the destination is still on the map. Each of these is valid. Yeah, so I guess what they are doing is what I mentioned, where you don't just put things on the work list, because if you took a turn, you better just consume all the steps, the 4 minimum steps. But somehow they managed to squeeze that in 16 lines. So that's cool.
Wow.
Heap up.
Yep, that's the heap library I was thinking of.
These names are overloaded. Heap can mean different things for different people or for different programming languages and stuff. So what is a heap in this context?
It's like an always sorted, like it has that structure where the maximum item is at the top, and then like the 2 second top, like one and then the other. Do you see? It's like linearly organized so that you have the maximum item at the top. Actually, a better way of saying it is it's a binary tree, but it's arranged in an array normally, where the maximum item is at the top or the minimum item is at the top.
It is like a priority queue. It's like a list with
I think
built-in
sorting is the
sorting.
same thing as a heap.
And then when doing a heap push,
like,
I bet that you have to specify how, or as push, you have to specify how you define what it means to be greater than.
I think maybe by default it's in one direction. It's like the minimum or maximum if it's like integers or whatever. So it doesn't matter.
What is this?
But the main thing is that that's the walrus operator. It's knowledge coalescing. But I think the main properties of heap are that it's like all the operations are log n. So similar to a sorted doing binary search for sorting and inserting, but you always have the maximum and the minimum in the same place.
Yeah, this is very short.
Does that make sense? Is that what you were thinking was heap? It's been a while since
I was thinking of heaps as like stack versus heap in
right memory.
Yeah. I'm more of a programming language person. Why does my camera keep doing that? It shouldn't do that. I don't like that it does that. Ah, okay. I like that, but this is pretty cursed. This is probably the way that they are changing directions. Pre-written Dijkstra. Yeah, people are just trying to get it as fast as possible because there isn't any other insight, I guess. There is a visualization. The visualization runs fast. Yeah. Cool. People bragging about doing it fast. It's just an XOR?
It's just an XOR.
Even turning is optimized. Ah, turning is on XOR. Okay. The solution with a binary heap and cache will stay as is.
Did they create these spoiler things?
I don't know. I think it is a Reddit feature because probably subreddits for like TV shows and stuff will want to use it.
Mm.
Oh, my camera froze again. Lovely.
Are you thinking of, is this giving you inspiration for course law?
Maybe. Let's think for a second. Why would people want to have spoilers in an educational setting?
Because you want to be able to give people hints without giving people the answer, and you want to be able to read.
But students will just click on the hint. We'll just reveal the spoiler, right?
Yeah, but their goal is not to pass the exams; it's to learn in some ways, or like to get. Or like no, that's not true. Their goal is to pass the exam, and cheating won't necessarily help them do that. If they take hints and then, one by one and think it themselves, then that might improve.
Yeah. The professors that I work with are much more jaded. They have a very bleak view of students.
Yeah. But it might be one student commenting for another.
Dijkstra with simple. I want to reread the Dijkstra's algorithm Wikipedia page to learn about all the ins and outs and the tricks. But it seems like in this one there isn't a lot more to
is better than Dijkstra. I actually implemented A-star for a fun use case once. I built a routing algorithm for finding safely lit paths in London. So for basically for vulnerable people walking home, girls walking home basically at night. So we implemented a little app that you can use to find well-lit routes, and all the data is just on OpenStreetMaps. And I implemented A-star routing algorithm. It was fun.
I'm gonna look into that, and let's just check if there is a Vim solution. There is not. So with that, I think we are good to go. When is the time that we are meeting tomorrow?
Up to you. Although I'm not sure I can do 10 a.m. tomorrow. Let me double check. I can do 10 a.m. if that's what you prefer. Yeah, I'm busy at 2, but yeah.
Let's do 10 a.m. Let's do 10 a.m.
Yeah. Okay. Cool. I'll see you at 10 a.m. tomorrow.
I'll see you at 10. Yes.
All right. I look forward to it.
All right.
Have a good evening, Leandro.
Thank you too. And thanks to everyone who was watching. Bye-bye. See you tomorrow.
Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.